In 19th century industrial cities, factories expanded, railways multiplied, and machines ran longer hours, demanding precise engineering inside workshops, depots, and power rooms across empires. Industrial growth relied on standardized systems such as rail maintenance schedules, lubrication routines, and electrical circuits embedded inside factories, rail yards, and urban infrastructure rather than individual invention stories. Within these expanding systems, engineers from marginalized black communities worked inside machine shops, railway companies, and patent offices, contributing solutions necessary for industrial continuity and safety. These engineers rarely controlled factories or corporations, yet their technical designs became routine practices inside rail networks, lighting systems, and manufacturing plants across industrial economies. Welcome to History and Society, where we explore how systems quietly shaped civilizations, long before people understood what was happening. Industrial systems recorded outputs, patents, and profits, but often detached engineering improvements from workers whose racial identity limited institutional recognition within corporate and legal frameworks. Railway networks required constant lubrication to prevent overheating, delays, and mechanical failure, turning refinements developed by black railway engineers into system-wide necessities across transport grids. Factories adopted these refinements not as personal innovations, but as standardized procedures written into manuals, maintenance logs, and training practices governing industrial labor forces. Electrical infrastructure followed similar patterns, where drafting rooms and utility companies absorbed improvements from black electrical engineers, while individuals remained institutionally invisible. Over time, industrial memory favored companies, systems, and brands, while engineering labor from black communities disappeared into routines that powered cities without attribution. As rail networks expanded across continents, companies demanded reliability, forcing workshops to formalize maintenance routines, inspection schedules, and mechanical standards across national transport systems. Patent offices became central institutions, translating workshop solutions into legal documents that transferred engineering knowledge into corporate ownership and long-term control. Engineers working inside railway depots often submitted designs through employers, losing direct claim as companies registered improvements under corporate names and industrial subsidiaries. This process favored firms with legal access, education networks, and capital, while skilled engineers from black communities navigated restricted patent systems and contractual barriers. Over time, railway corporations standardized these absorbed designs into manuals, rulebooks, and training schools that reproduced engineering knowledge without reference to its original creators. Industrial training emphasized repetition and compliance, ensuring systems survived worker turnover while separating technical skill from personal recognition within factory hierarchies. Similar patterns emerged inside electrical utilities, where grid expansion required standardized components, safety protocols, and communication systems governed by centralized companies. Drafting rooms transformed individual problem-solving into corporate diagrams, embedding engineering labor into blueprints that outlived the people who produced them. As cities electrified, power companies accumulated patents, franchises, and municipal agreements that consolidated control over urban infrastructure and technical decision-making. By the early 20th century, industrial systems no longer needed to remember engineers because procedures, documents, and institutions carried their work forward silently. Factories expanded alongside railways and power grids, organizing labor into departments, shifts, and roles designed to maximize output and minimize dependency on individual workers. Engineering knowledge inside factories became segmented, separating design, maintenance, supervision, and manual operation across layered industrial hierarchies. Skilled engineers from black communities were often placed into technical roles without authority, executing critical processes while remaining excluded from managerial or ownership positions. This separation allowed factories to extract precision and reliability while preventing engineers from translating technical control into institutional power. Time clocks, punch cards, and production logs tracked performance, embedding human labor into mechanical rhythms governed by schedules rather than expertise. Industrial efficiency depended on repeatability, where machines and procedures mattered more than who originally refined or stabilized them. Training systems reinforced this structure, teaching workers how to follow established methods without questioning origins, authorship, or design intent. As factories scaled, engineers became interchangeable within systems that valued continuity over creativity and compliance over recognition. Racial hierarchies inside industrial societies reinforced these outcomes, limiting advancement while preserving access to skilled labor where it was economically necessary. By design, industrial production masked human contribution, allowing systems to function smoothly while erasing the engineers who made them reliable. As factories and utilities grew, governments introduced inspections, licensing boards, and safety codes that tied engineering practice directly to state authority. Regulation protected infrastructure reliability, but also centralized approval power, determining which engineers could certify designs, supervise works, or sign technical documents. Access to these credentials often followed education pathways and professional networks that historically excluded many skilled engineers from black communities. Unions emerged to negotiate wages and conditions, yet leadership positions frequently mirrored existing social hierarchies within industrial societies across expanding factories. Collective agreements, standardized roles, and pay scales, further separating engineering skill from individual identity inside regulated industrial workplaces, nationwide systems. Visibility followed titles and certifications, not technical contribution, reinforcing systems where recognition depended on institutional approval rather than practical mastery. Engineers without formal credentials continued solving problems on factory floors, rail depots, and power rooms, while remaining officially unrecognized there. Regulatory systems preserved stability, but they also fixed social boundaries, deciding whose expertise could advance into authority within industrial states. As industrial nations matured, engineering became a licensed profession aligned with universities, corporations, and state institutions across expanding urban economies. This alignment shaped who appeared in records, textbooks, and leadership roles, while other engineers remained essential yet unseen within industrial history. As industrial expansion slowed, archives, company histories, and technical journals became primary sources shaping how engineering progress was remembered and taught. These records favored executives, institutions, and patented breakthroughs, compressing complex collaborative labor into simplified narratives of corporate achievement. Engineering manuals and textbooks repeated these selections, teaching future engineers systems without histories and techniques without social context. Contributions from engineers outside elite institutions faded, especially where race limited access to publication, citation, and professional visibility. Museums and exhibitions reinforced this pattern, displaying machines and diagrams while separating technology from the labor cultures that sustained them. Public memory celebrated invention moments rather than maintenance systems, privileging origin stories over long-term operational refinement. Black engineering labor remained present in infrastructure, but absent from official storytelling frameworks that defined industrial progress. Over generations, this absence hardened into assumption, where invisibility appeared natural rather than produced by institutional filtering. Industrial societies inherited functioning systems without inherited recognition, mistaking silence in records for absence in reality. By the time historians looked back, systems spoke loudly, while the engineers who stabilized them had already been written out. In the late 20th century, scholars revisited industrial archives, questioning why systems appeared fully formed while records of everyday engineering labor remained fragmented or missing. Historians encountered company-led documentation that emphasized outcomes, patents, and executives, while offering little insight into workshop-level problem-solving. Oral histories and community records revealed skilled engineers from black communities whose work sustained railways, factories, and utilities without formal archival presence. These sources challenged official narratives, but lacked institutional weight, making integration into textbooks, museums, and curricula slow and uneven. Technological systems complicated recovery efforts, because maintenance improvements rarely carried signatures, dates, or personal attribution within industrial documentation. Unlike landmark inventions, incremental refinements disappeared into procedures, manuals, and training practices that masked their human origin. Reassessment exposed how industrial history privileged visibility aligned with authority rather than technical contribution grounded in daily operational necessity. This realization shifted focus from invention moments towards systems, stability, labor distribution, and institutional filtering mechanisms. Yet correcting historical absence proved difficult, since recognition depended on records designed originally to exclude many engineers from acknowledgement. By the time reassessment gained momentum, industrial memory had already solidified around corporations, brands, and formal institutions. Modern infrastructure still carries the imprint of 19th and 20th century engineering decisions embedded in rail standards, power grids, and factory layouts worldwide. Cities operate through inherited systems, where reliability depends on routines refined long ago, rather than celebrated breakthroughs remembered by name. Maintenance cultures continue prioritizing continuity documentation and compliance, reinforcing structures that value procedure over personal authorship or historical acknowledgement within institutions. Efforts to diversify engineering histories face limits because modern organizations inherit archives shaped by earlier exclusions and institutional priorities alone. Recognition initiatives often surface. Individuals yet struggle to reconnect systemic processes with the labor structures that produced them historically industrially. Understanding industrial power requires shifting attention from names to mechanisms, examining how systems absorbed expertise while distributing credit upward institutionally. This pattern was not accidental, but structural, emerging, wherever corporation states and markets intersected with engineering labor over time repeatedly. By tracing these structures, viewers can see how invisibility functioned as a feature enabling scale efficiency and control within industry. The industrial world was built through accumulation, where countless refinements mattered more than singular moments of invention across sectors globally. Recognizing this changes how history is read, shifting focus towards systems that endure and the labor that sustains them daily. Industrial systems endure not because they remember people, but because they convert human effort into routines that survive replacement expansion and institutional change. Engineering history often appears complete precisely because omission created smooth narratives free from contradiction, struggle, and unequal recognition. Seeing what was excluded reveals how power organized memory shaping, which contributions became visible and which were absorbed without trace. This does not require rewriting machines or rebuilding infrastructure, but re-examining how systems assign value, credit, and permanence. When systems grow large enough, individual labor disappears into scale, making invisibility a condition of efficiency rather than an accident. The industrial world still operates on foundations shaped by this logic, where contribution and recognition remain structurally separated. Understanding this separation helps explain why progress often feels anonymous, even while depending deeply on skilled human work. History becomes clearer when systems are studied not as neutral tools, but as filters that decide what is preserved. By following infrastructure, rather than heroes, patterns of power, continuity and exclusion come into focus quietly. This is history and society, where understanding systems reveals how the modern world was built and why it remembers the way it does.